Hello and welcome back to quicktechie.com. Now in this session we will cover hands-on exercises around 6 to 7 hands-on exercises in this session we'll cover and few of the FAQs related to that exercises which we will discuss as part of. So this is the lab environment which is provided by quicktechie which you can launch using just this link. So just this lab is very specific to you. So you can click on this and you can launch this. So once you launch it, this is initially very blank because nothing you have executed on this lab. So now these are the exercises which we will be completing as part of this session. So let me start with exercise 1 and I'll discuss few concepts during this exercise, like these are the FAQs which I have covered uh, as part of this. So this is what I have prepared for you. Okay, so let me go through this and exercises, and then I'll come back to this question and answer. So this is the PDF which I will share with you. So all the required data which you need to run the exercise is also provided as part of the lab. So you don't have to explicitly download or anything, you have to do. So now let me start with exercise 1. So define a case class for Hadoop exam course detail. Suppose if you are having an Hadoop exam course and you wanted to run some analysis on those data which is Hadoop exam is producing. So what we are doing it here, we are creating a case class. So what exactly is the case class? So here you can see a Scala case class is like a regular class. So in Java or Python or Scala or any object-oriented programming language, you need to know the class, how to create that class. So similarly, Scala has a case class concept, which is exactly same as your regular class, but it has a few special characteristics. Like when you create a Scala case class, it generates an immutable object of that class. It also serves in the pattern matching. So whenever you need to do pattern matching on Scala, such class is default apply method which handles the object construction. So like similarly in Java you have a default constructor. Here it has an apply method which can be used to create a object. A Scala class or class have all value as a vals. Where there are two type of variable and vals. Vals are static, so you can't modify, which means they are immutable. So any case class object which you create, it is immutable. For example, here you can see here case class message we created with three input here, sender, recipient, and body. So this is for email object. So message one you created, this is the sender, this guy is a receiver, and this is the body of that email. You would print it and it would print this value because this is the sender. And if you try to reassign to different email ID to sender, this line would not compile. So that is what immutable means. Once you create an object, you can't modify it. So you can't reassign message to the sender because its value is immutable. It is possible to use wheres in case classes, but this is discouraged. So this is not very strict, but you should always make sure case classes, if you are using it, means any developer is assuming they are creating immutable object of that class. Okay, so now similarly for Hadoop exam course, we are going to create a case class like this. So HE course is the name of the class, ID is an identifier for that course, and what is the name of the course, what would be the fees of that course, and where it is conducted, venue, and what is the duration of that course. Correct, so that is what. So let me copy paste this code here and run it in your lab. So this is your lab here. So you can simply paste it, and here this is the play button. You can run it. Let's see. If you're running first time, it may take a bit longer, and you may have to wait for some time. And once this is completed, you would see the response as well. So it is running. You can see here it's still 0%. Okay. So let's wait this to be completed. And meanwhile, let's move to the next slide. So encoder concept we have learned in our previous session, like what is the encoder? Encoder are serializer and deserializer. So we wanted to use this case class. So that is the reason we wanted to have default serialization and deserialization, which Spark provides, needs to be implemented. So what we are doing it, we are trying to generate schema using the encoder class here, encoders.product. This is the HE course, and we are asking for the schema. What is the schema of this case class? So we are converting this case class definition to in a schema format, and that schema we wanted to print as a tree string. So let's try to run it and then you would understand. So here you can see that this is an output, define class as an HE course. So this is an output. Now if I run next segment of this code, I can copy paste from here and let me paste it here and I would execute it here. So now you see this is bit faster, correct? And so these are the two import statement here, and encoder, you can see we got that schema and that schema is printed here. So what it says, ID is an integer as we define, name is an string class, so it is saying string, fee is a integer, value is a string, and duration is an integer. So that is what we have printed here. So if you see encoder schema object, if you see exactly this is the format it has, struct type, struct field, and all this basically, correct? So but here we wanted to print it which human can easily understand, so that is the reason we have used the print tree string method. So that is what you can use whenever you want if you don't understand, because this reading this line is a bit complex, correct? It is not easily understood. But when you want to define your custom schema, you can use this method as a struct type, and struct type is the entire your schema for this, and then struct field, each field is represented by struct field object. The same thing you would see in your question answer as well. Somewhere I have mentioned here, you can see question 4. Spark SQL struct type and struct field classes are used to programmatically specify the schema to data frame and creating complex column like nested struct, array, map, and column. So few more exercises as we will move, you will learn about this, correct? So I'll skip for now. So this is what we have printed. Now next, what we did, we have defined class, but we have not defined any courses or something. So we need to create a actual courses which are going to happen. So what I'm going to do here, I'll create a sequence of HE course object, like 5 courses we will create here. So first identifier is 1, the name of the course is Hado, fees is 6,000, and location is Mumbai, and duration for 5 days. So similarly, I have created 5 object, and that is what an RDD would be created. Exactly, this is an SC dot parallelizes. SC here is what, Spark context, correct? So that spark context is by default available, so you would create this and it would return you the RDD. So let's run this code and then you would understand what exactly it means. So you can run it here itself, correct? No need to like always create a different paragraph here. So if you run it, it would rerun basically from start to here, correct? And then you can see here like a parallel collection RDD 0 is created. So this is an RDD course, RDD is created here. Now let's move here, and now we wanted to convert that RDD into the data frame. So as I have been saying previously, if you are using even Scala or Python or SQL, always try to convert your data into data frame, because that would give you lot of benefit, and you should always work on the data frame as much as possible, okay? Or temporary views or kind of thing, so that we will learn further. Now here in this we need to do a import spark dot implicit. What does implicit means here? So that is again here I have given you entire description here, so I don't want to just read it, you can go over here. But implicit means like you can import anything and that would become a part of your scope. So the Scala allows you to import dynamically wherever you want. You can import in your code. It is not necessarily always the top of the code you would import it. You can import anywhere, and you can also do something like that as this is example here. And so this is what implicit would entirely help you to convert Scala object to a data set, convert Scala object to data frame, or convert dollar name into column value. So that we will, again this one we will see later, but this is what you can read it entirely. I have prepared this, so I'll share for with you as well, so that clear your concept as well. Okay, so that is what you would see most of the places we are importing this implicit object by default. What we are doing it now, course RDD to data frame. The 2DF method we are using it to convert into data frame. And then we are again printing the schema from this data frame which we have created. So let me copy and paste this code. And if I execute it, so here you can see again the same schema is printed here, correct? Using the 2DF, and we have created. and it also print whether this object value is nullable or not. ID integer nullable false, it cannot be null, and name string can be null, c integer can be null. Okay, so that is what it has identified by itself when you created a data frame. So it has derived whether this value can be null or not by itself. Okay, so now so that is what in our first exercise which we have created an RDD and RDD2 data frame we have created, and from this data frame we have printed the schema. Now let's move to next exercise, define column names without case classes. So one example we have seen using the case classes. What happen when you have a lot of fields, let's say around 50 fields to define for your data set. So how would case classes are helpful? No, case classes has limit of 22 fields you can define in a case class. You cannot have a more than 22 field in a case class. So that is the limit Scala has defined for the case class. So if you have more than 22 fields, you should not use the case classes, and you should use specifically different way to define a column names. So let's see the example again here. So here we are importing this, and I would create a case class, this without case classes. From this sequence, we are creating the RDD basically, correct? So let me start with the new lab, not new lab basically. I would start with the paragraph here on top. So anything which is already done at the bottom should not be used. So like it isn't used in sequence, whatever variable you have created, correct? So you should always run at the top. So let me copy and paste here till here. So when we execute this, so you can see this is an RDD created with this flag. Okay. Now I'll convert this to data frame which we have seen previously. So I'll paste at below of this only, and this data frame would be created here. So you can see here data frame, and here you can see like column name is _1 _2 and kind of thing, correct? So let me print here schema, so that would be more clear to you. So here you can see like all column name, because we have not defined anywhere the column name, correct? So there is the output. Okay, let me rerun. So here you can see this is an output here, which is all the column names are not having a name proper. So what we can do here, we can use 2df method again, like it's like in a 2df method itself we can provide the column name here. So let's say you can just see here, I wanted to use this this data frame, correct, and then assign a column name while converting into data frame itself. So let me put it here. So here you can see, so you can see here it is saying it is already defined because it's a well. You cannot redefine it. So you have to give a different name while doing this activity if you are trying to do this. So let me just for now give me the name like this, and so here you can see now another data frame is created, but it has a column name in it. So now if we print the schema for this data frame which we just created, now let me give the data frame correct name. So you can see here this has a correct column name. So what we did in this exercise, we created an RDD using our data set, and this data set was converted into data frame first, but data frame without column name is created. So by default, Spark has provided column name _1 _2 _3 and like that. So this is not good. So we wanted to define our own column name. So what we did by creating two df functions, by converting to data frame itself, we provided the column name and it had assigned those many column name to this class, and it had created a new data frame. So what is the use of the this way of doing? Whenever if you have less than 22 fields in your data set, then you can use the case classes. If you have more than 22, then you can use this way to define your column name to create a data frame. Okay, so now let's move to the next exercise, converting RDT to the data frame using Spark session. Okay, so let me just go through here. What is Spark session here? Spark session is a unified entry point for Spark application from Spark 2.0. So previously, if you have worked on Spark 1.6, 1.3 or something, then you would have always used Spark context. But now Spark 2.0 onwards, now we are on Spark 3 plus, correct? Now and we are using Spark session to enter into the Spark, and it provides a way to interact with various Spark functionality with a lesser number of constructs. Instead of having, like, if you wanted to use previously Spark context for file processing, high context for high connection, SQL context for SQL query, and this is all encapsulated into a single object that is called Spark session. So that is what Spark session. So what I would do again, we would create the same way which we did basically on our case. Without case classes, we'll create an RDD and then create a data frame and print schema, which we already did here till here, correct? So let me uh, copy and paste this code here in a new paragraph now, correct? I'll run here this, and now you can see this is how generated. Now I would create a data frame with the column name, and that is what we already did. So I'll just copy paste here, and same error will get here. So to handle that, using Scala operator to exclude columns array to comma separated values. So now we define sequence of column names. So I can have a lot of column names, correct? So I would create a Scala sequence object from them, and here in 2df method, I can copy paste here this as well, correct? But this is another way. Just wanted to show you, like, you can use the explode way of like he columns column underscore star. So this way it would entire your sequence will be replaced here and would be used to. So it is very same code. The only way is the to differentiate how you provide column names in the 2df method. So this way you can separately create all the column name sequence, and then use this here using the explode way. So let me put it here again, and again I would create two here, and then you can run it here. So now you can see this is how your um, entire value will be printed here. Sorry, schema will be printed here. Okay. So this is now exercise 3. Now exercise 4. Okay, I forgot to mention header here. So let me just go over this exercise, what it does, and then uh, we'll see. It's more about talking about the raw object of this. Let's see. So we would again import whatever we is required, struct field and struct type. Now we are using struct field and struct type to create a schema. Okay, and here you can see sequence of the column name we have defined. We are creating same RDD here again, correct? And then we are defining struct schema ourselves using struct type. So struct type would be your HE columns. HE column is what? This is ID, name, fee, value, and duration. This is your iterating over here, and field name, and you are saying field name, string type, and nullable equal to true. You are marking everything is nullable as is true. So this way it will be created. What we are doing here, we are saying every field is a string type. Okay, here. So let's see in action, then would be more clear. So let me copy paste this code here, and let me create another paragraph here. run this. So now your RDD is created. Now what I'm doing it here, I'm defining a custom schema here. So HE schema would be created struct type. Now what it says struct type is missing here. It means I need to provide here an import statement. Most likely that should solve this problem. Yes, now it is solved here. Now we will create so we have created HE schema as a schema we have defined here. So it should be somewhere here. So you can see this is the schema we have defined for this. So what here we are saying is, you can see here ID is also string and name is also string, fee is also string, because we have iterated here using lambda function of Scala to create a type sequence and use it for our data. So now I'll use it using this. So let me just run this here. So here you can see on RDD will be created, ROW RDD, row RDD. Using case classes, what we have created here, two objects we have defined in a row. One is attributes one underscore one and another is attribute two. So two fields in a each RDD we would have, like each record in RDD we would have. Now what we are saying is, using this RDD create a schema. Sorry, assign a schema to an RDD and create a data frame using that. So if you see here, when I run this code here, you can see, okay, somehow it is not printing here. So let me move further, and here we can see a print schema here. So if I run this code now, it looks like there is some limitation on the out. Okay, sorry, my bad. So this is an output here. If I expand it, then you can see this basically. So we have to expand it further. So now you can see this is an schema has been created for this, and every value is a label equal to true, and every data type is a string here, as you can see here. Okay, so that is what we did here.